we're looking at titration examples. In the previous video, we did 2 examples with equivalent amounts. Very straightforward. Now we're going to try non-equivalent amounts. So find this question on the 3rd page of this section. Here we have HI being titrated against KOH. So we've got a strong acid, strong base. And there are 5 points where we want to determine the pH. And 2 of the points are really easy. It turns out that A and D are going to be no problem. But B, C, and E are going to require more work. And what we have to realize in this titration type question, we're actually going to worry about the total volume of solution that ends up in our flask. In the previous titration, we didn't care about that at all when we were trying to do an equivalent amount titration. But here we have to figure out our total moles of acid, total moles of base, which is limiting, divide by the total volume, get either H plus or OH minus and convert to pH. So we're throwing things at you fast, but this should make it fairly straightforward. So here is our equation. And we know when we've added no KOH, all we have is the HI. We're told it's 0.100 m. It is a strong acid, so its pH is 1.000. Notice we had 3 sig figs here, and the numbers that trail the decimal point are significant digits. Number in front is the power of 10. B is going to be more obnoxious. So what we see is we had 25.00 milliliters here, 24.50 milliliters here. So we had 0.50 more milliliters of the acid. So it's going to be in excess. So we've done our moles, got our moles of each thing. There's our moles in excess left over. But now we have to add our 2 volumes together to get our total volume. And we do this, we divide, we get 0.001, and our pH is now at 3.0. In question C, we're getting closer. C, we're just 0.01 mils away from being the equivalence point. Exact same procedure, volume concentration, we get the moles of each, and we see the HI is still barely in excess. So we have this tiny number of moles. I'm kind of neglecting sig figs. I divide by my total volume, and now the pH has moved from 3.0 roughly to approximately 4.7. There's a certain amount of latitude there. D we love. It is so easy because this is a strong acid, strong base titration. We now have equal moles of both the HI and the KOH, and therefore our pH is 7.000 because it's a strong acid, strong base titration. So now we go to our last question, E, and finally the KOH is going to be in excess. So remember, we start with low pH, we got to 3, 4.7, 7. Now we know we're going to be above a pH of 7. Again, 1-to-1 deal. Again, figure out the moles of each. This time the number is just slightly bigger. We take that number of moles, we divide by our total volume, and we get this number 0.0001 big M. And we get a pH of, or POH of 4.0, because remember that was OH minus, and that converts to a pH of 10.0. So, we have 2 sets of questions for you from the textbook. It talks about reading certain pages and doing questions. And what they're talking about is, hey, 60 to 65, those are regular titrations, the kind you're used to, very straightforward. And the non-equivalent amounts are on page 597. So these are questions that I will post on the deadlines to let you know when they're officially assigned and when they're due. But these are some of our more complicated notes when it